Alright guys, welcome back to a new severe weather forecast. Today we're going to be talking about the potential for back-to-back significant severe weather events next week. So stay tuned. Um and yeah, currently we're going to be looking at the SPC page as we have a day 5 15% risk encompassing portions of southeast Oklahoma, western central Arkansas, northwest Louisiana, and northeastern Texas. What this means is that scattered severe thunderstorms are possible anywhere in yellow and in a 25-mile radius of anywhere in the yellow colors. So big cities like in the risk area include Tulsa, Wichita Falls, Waco, Lufkin, Shreveport, Dallas, Arlington, Plano, Garland, Fort Worth, Texas, Little Rock, places like that. The next day, day 6, another risk of severe weather exists anywhere from southern Illinois down to the Gulf Coast. Places like Nashville, Bowling Green, Birmingham, Mobile, Jackson, Memphis, Mississippi and Tennessee, Memphis, Little Rock, Shreveport, Alexandria, Birmingham, Montgomery. Just a couple places that are going to be included. We're first going to be looking at the NAM and the RDPS. NAM wise, looking at the NAM and the RDPS here. So we're going to first kind of look at the precip pattern here just a little bit. We get a little bit of a winter storm out there for the Northeast over the next few days. Some light snow for Illinois too, and parts of the Midwest with a little clipper system for them tomorrow. Just some light snow showers. You can see here, there's that system there. We have a 1001 millibar low as we get to 12Z on Wednesday. We also already seeing 50-degree dew points being advected onshore with 60s and 70s out in the Gulf to be stored up there. Let's take a sounding. Let's take a sounding at DFW at this point at 12Z. We see here a very strong EML in place, which will give us some solid lapse rates. No real instability at this point. A good hodograph as well. No severe weather would be happening at this point, not even convection. But looking at the 500 millibar, a very significant system. This would eject over in here, giving them a severe risk depending upon the moisture return. It also has a really significant LLJ compared to some of the other models at this point as well. Let's look at the RDPS. Pretty similar stuff. Northeast winter storm, not really significant. And then here's your system. Here's your dew points. It's around the same amount as the NAM, if not a little bit more. 55 at DFW still. Similar cap as well in place at this point. 500 millibar. It looks a little bit weaker than the NAM, I will say. A little bit weaker at 500. It also is a little bit slower at 500 millibar as well. Actually, that's a little bit faster, I'm pretty sure. Yeah, it's a little bit faster. A little bit faster at 500. A little bit further south as well. Also looking at the 850 millibar winds, very similar. Wait, no, that's 850. 850 is very similar to the NAM as well. Let's look at the GFS now. We're going to be going pretty good in depth with it. Let's just start going out here. Here is when we start to see the low pressure system start to develop. Kind of sits back there. This is when it starts deepening. The new runs have been slower and slower, meaning that the Dixie Alley risk the next day would be higher and the Plains risk would be a little bit lower. We see thunderstorms and regular thunderstorms. It looks like thunderstorms would be happening kind of in here at this point. Some of these could be severe, especially in areas like Oklahoma, southeast Kansas, maybe southwest Missouri, Arkansas, Texas, and Louisiana at this point. Here's 03Z. We start to see the system really go off, and we start to see it deepen low in central Arkansas at 12Z. We have a 15Z. We have the low in western Kentucky, and then at 18Z, it's up near Evansville, Indiana. I did not mean to have it like that. We would probably have a line of strong thunderstorms at this point. Don't really look at the reflectivity for any real value. It's just there to show you the pressure, and it really starts deepening as we get toward 21Z. And then looks like the system goes off the coast there. So around 9Z is when your severe threat would stop, if the GFS was correct. Now, I will have another window open. This is going to show a different system in the late run. I'll show it right now. There's another system in the late GFS run and other runs of models that has been creeping up and showing up, being pretty significant, and this would bring another severe risk to Dixie Alley if this was true. It would also bring a winter storm potentially to some areas along the cold side system of it. Now, this system is around 240 hours out, so note that it will change a lot over the next few days, but the signal is there. Now, let's go dive into our severe weather event a little bit more significantly here. Let's go look at the hour 84. So the GFS is similar to the NAM, but the NAM's a little bit more intense with it. Seems like the NAM and the GFS are at similar speeds as well. As we get into the next day, into Oklahoma here at 3Z, we start to see the trough get going there. Solid 500 millibar winds. 850 isn't terrible either. It's not as great over the plains. We see theta E of around 320 Kelvin to 330 is being advected onshore. If you look right around in northern Texas there, we will see it's very capped. The new GFS run has been showing a heavy cap with this event, meaning the main threat would be damaging wind gusts and large hail if that came true. There's less of a cap there in northeastern Texas, so maybe if you get a storm out there, you'd have a little bit more of a tornado risk with this. Now note that I'm not going to go too much into mesoscale details, but if the GFS were to be correct, the tornado risk would not be super significant for the 16th, but I don't really know if people were really expecting it to be that significant. Let's get to 12Z here. We have a large warm sector with very strong 850 millibar winds. This is when a significant tornado risk would be possible in Louisiana, Arkansas, and Mississippi if the GFS solution were to be correct. We're going to take a little box sounding here, encompassing a lot of areas in Mississippi, Louisiana, Arkansas. As you can see here, we have a very enlarged photograph with SRH around 300 at 0 to 1 kilometer, along with some strong deep layer shear, a little bit above 60 knots. Lapse rates aren't particularly great in the low levels, along with a solid cap there, right around 850 to around 1,000 kilometers there. Instability is rather marginal at this point as well, but it would get the job done given the very good photograph and other dynamics. Around 15Z, the GFS risk really maximizes there. We see, I would likely expect these surface temperatures to be maybe pushing more like 60, maybe uppers, a little bit higher in the upper 60s or low 70s at this point. We see very enlarged photographs still in place, along with some marginal instability still. Mid-level lapse rates get the lapse rates get a little bit better. Mid-levels cool off. Mid-level lapse rates aren't as great though, but that's because the EML wasn't as significant. Very significant wind shears as well. Still, let's look at the 850 millibar winds. At this point, they get a lot more widespread and a lot more significant. Anywhere in those yellows, that's 60 knots and above. Here's your 500 millibar winds at this point. We have a pretty significant amount, is 70 plus knots across the warm sector, and then there's your 200 millibar. Those are around 120 knots. Here's your 925 millibar. This is really low level, 50 knot low level jet at the really low levels, almost surface. If we were to look at the Cape with this run, it's pretty. Just look at this range. Just look at the area it has. It has an area from Texas into Louisiana all the way into South Tennessee there. and then down through Alabama. That would be your severe risk at 15Z. Now, given that convection would be hanging back more toward Arkansas, Louisiana, that area there, if the GFS were to be correct on that, that's where you have it. Here's your surface winds, though, and as you can see there, they're pretty high, especially 20 knots. That's a little bit near the squall, but you have a really strong hodograph there. And if we go a little bit more north in the Mississippi, we see less amounts of instability, but very strong shear. Now, as you get a little bit further south, you see less amounts of shear, but you see a little bit more instability as well. Once we get to around 18Z, we start to see the system deepen more, bring low 62 points into southern Kentucky. At this point, I would probably, given the fact that you have some MU keep up here, probably a severe risk would be possible only from Kentucky all the way into Louisiana, Mississippi, into Georgia probably. And then as we move on here to 0 to 21Z, it moves into the Carolinas and Georgia more or less. And then this is when the Carolinas and Georgia would have a more significant risk off the GFS and a lot of other models too. Oh yeah. Let's look at the Canadian model now. So let's take a look here. Now the Canadian model is a little bit too far south of low pressure in my opinion. I don't think it's gonna be that far south. And it's pretty weak with it as well. But it shows a pretty significant event, especially across portions of Mississippi there. If we take a box sounding there in Mississippi, off the Canadian model, we see very strong wind shear, especially in a very solid hodograph. Classic Dixie hodograph, with really good upper level wind shear, good low level wind shear. The instability is not great, but the surface temperatures are a lot better than what some of the other models show for severe weather, more conducive. Once we get to around 60, this is when the Canadian brings a more significant severe risk to the Carolinas and Virginia. Probably in here, maybe a little bit further south and south and west as well. But don't discount that there is a severe risk late night in portions of anywhere from Georgia, maybe Alabama, and Florida into Virginia. We take another box sounding here in areas like this. You see, once it loads here, a very solid hodograph, very classic squall line hodograph at this point. Veered winds in the low levels there. So this would be a QLCS wind and tornado risk. Marginal instability, but given that you have strong kinematics and the squall line would probably already be ongoing, you'd probably see a tornado and damaging wind risk. Also, if you look at the 850 millibar wind shear, it is very strong, 70, 80 knots at this point, with a solid amount of 500 millibar wind shear as well. Let's look at the UK Met model now. We're going to look at the 10 millimeter wind. So here's your system starting to develop. This is Tuesday. There's Wednesday. The UK Met is being way too progressive with the system. It already has the low in northern Texas at this point. Most of the other models don't have it being right there at this point. They have it being a little bit further south, and they also have it being more southwest at this point. It doesn't go super fast at this point. We see if we take soundings in that area, they're very capped. But at this point, most of the models have the low pressure being more down here. Most of them have it being kind of in this general region in here. Maybe a little bit further south as well. But they don't have it being so far north, and they also don't have it being super progressive. So I think the UK Met is being a little bit too progressive with the low pressure. And then at 18Z, it has it all the way in Michigan. But nonetheless, this model does have a very solid solution for severe weather. Even into Alabama, we still have very good surface winds, and we also have strong amounts of dew points. This run would probably bring some more severe weather into Ohio, maybe? No, a little bit too weak of instability, but it would bring severe weather a bit further north than some of the other models. Like, yeah, it has Indiana getting, or that'd be Kentucky getting a severe weather sounding there. But as we see here, we have pretty solid amounts of dew points into the area with, again, Very strong wind shear and marginal instability. That's the main theme. Now, I do expect the values to be a little bit higher than what some of the models show, given the fact that the PBL cold bias is taking play again with these winter events. We still have a very solid low-level jet off the UK Med, and then we also have some solid 500 millibar wind energy. Now, it is a bit further north because, like I said, the system is a little bit further north. Expect this piece to probably, this energy piece to probably be more in this general area, the big time piece, and then have more of the reds go down a little bit further south than what the Canadian or the UK Met shows, but it's whatever. I did forget to show the Canadian synoptically too. Here's what it has synoptically at the main point of time with so it has a weaker system overall, but it is further south. Has strong mid-level or low-level support as well, with decent dew points and a surface low stationed in northwest Mississippi. If we do dive a little bit further deep into this and go out to the Carolinas at 60, or not Carolinas, Mid-Atlantic region, we still see that wave energy being there. We have very strong upper level, or not upper level, lower level wind shear at this point too. If we click a sounding there in that upper level wind shear ball up, it's pretty sheary there, of course. If we take a box sounding there in North Carolina and Virginia there, it's a little bit elevated, but we do see a very good hodograph and some very good shear, so I think this would be more of a damaging wind gust sounding. Now, there is some individual plot soundings that you would get more of a tornado risk for, but those areas wouldn't really be pointed out until later on. And once we get to 12Z, we see that system. We have 50 dew points all the way into Connecticut there. Maybe an isolated lightning strike with that if that would happen. But you can see the system moves out at this point. And yeah, here's the Euro. This is the old run. It's loading in right now. Overall, it's being a lot similar to the last run. It's pretty similar to the GFS solution currently. Very similar. So I think this run would be slower overall. Let's just take a look at the severe weather potential at 21Z. There is potential for severe weather on this day along in Texas and Oklahoma there. The instability and overall, it's been pretty heavily downtrending, I would say, and the main energy has been uptrending for the 17th, but this is a solid cold core profile here. We have dew points in the 50s and 60s. I wouldn't call this cold core, sorry, but this is a solid profile. Really good hodograph, but that hodograph won't be getting used as much as it could be if we had more moisture and overall instability. 0Z, though, we see a little bit higher instability, especially into more of a northeast, not Missouri, Oklahoma, maybe in southern Oklahoma as well. Yeah, but the cap gets a little bit higher. See the low placement. Let's see here. Oh, that is so similar to the GFS. So I think this run would be the last year run had the low at this point right here, but it had the system being super fast. Where does it have the 500 millibar wind energy at this point? Is it different than the last run? Maybe it's a little bit faster. What about the GFS? Is it similar to that? Oh, this is really similar to the GFS run. Now, this new run is very similar to the GFS. I don't know, might eject a little bit too fast still than what the other models show. So low as diffuse as the GFS shows it. They have the same millibar low at this point too. That's very interesting. And very similar reflectivity. This is like a copy paste of like the GFS run. But let's go back into looking at the ensembles. So this is the GEFS ensemble here. We have a very solid trough it shows. It already shows like a solid amount of wind energy being in play here. This is where it shows the speed max being placed up in this region, which is generally pretty interesting and probably the right area. If we look at the ensemble wind area, let's just look at the models that are unrealistic with it. This model, that is too slow, so that model's unrealistic. That's too fast. That's too far to the east. And what most of the other models show. It's a little bit too far to the east and north. So there's a few of them that are outliers, but most of them show what most of the other models show. Look at the spaghetti plot. It's very consistent with this. As we get further out and look at that event at around this area, yeah, the spaghetti plots are not so consistent. Now let's go look at the ensemble cape for the event on Thursday. Sorry, I have something stuck in my throat. But we can see here. Let's go into the Dixie area. We can see here. A lot of them have some areas with 1,000 surface space cape. I'll show you the ones that look to be more outlierish with the instability values. This one, this one, and this one, and this one. Those are like the 4 ones that I would say are more outlierish. This one's oh, and this one. This one's realistic. This is probably the low end realistic solution there. I feel like there's really, I feel like a lot of them show 1,000 cape in the Gulf too, which is interesting. Mean supercell composite. At this point, there it is. It's maxed at 12Z probably because that's when the max kinematics are. This is like the only supercell composite I would use, and I would use it for the area. So we have an area of severe potential in here at this point, and then as we shift, it goes further to the east, and it's more spread out, and then 0Z's up into the Carolinas. Now, here's the probability for over 1,000 cape, and it's a little bit higher than what it was earlier, but it's a little bit further south of this run as well. Probably because we have a little bit more inconsistency with it. Alright, that will do it. Thank y'all for tuning in, and we will see you in the next one.